my setup for today, and I am well, from the company FHIR in Amsterdam. The slides that I'm presenting today, they are available on the link that you see on this particular slide here. And I also have put this in the Q&A for anyone who wants to have quick access to that link. So please check the Q&A and find the link for my presentation there. So the FHIR company is a company that can provide you with all the training, tooling, and consultancy you might need to set your FHIR alight. And today, what we are going to take a look at is part of the FHIR ecosystem. So while some of you might have thought that we are an event company, we're actually not. And we provide you with these kind of tools that you see on this screen. Today, what we are going to focus on is this side. We are the profile authors. We are going to take a closer look at how to create profiles, or at least what is involved. We will not show the Forge and Simplifier tool unless we have time for a demo. But we also have a Let's Build session tomorrow where we will have hands-on experience. So today we will cover why we would need profiling, what the part of the FHIR conformance layer is. Then I will detail a little bit more about what profiles and extensions are and how you can create them. And we will detail some things about packages and registry and tooling. So that's quite a lot of topics. So hopefully we can get through this in the right time there. Okay, so why would we need profiling? You by now know that there is a FHIR specification, and that specification should be sufficient to tailor to all your needs, you would say. There are building blocks inside of them, but of course we all have other use cases. There are many different contexts that we have in healthcare, and usually that will mean that we still need a little bit of guidance or a little bit of things that we need to do in order to tailor exactly to that use case or context that we have. So profiling is something that comes in play there. We can describe which profiles or resources and elements we use. For example, also if you use the RESTful API in FHIR, which particular parts or features of that API can be used. Also, you can describe which terminologies you have in your context and how to map your local requirements to the FHIR specification. It is important to somehow be able to author all of these parts in a structured way, because if you have a structure, then that structure can be published. So we can publish that to a repository. Whenever people can find those structures, they can use them again to, for example, do validation or to create nice user interfaces from. So it's a nice thing to have if we can do this in a structured way. And that is where particular FHIR resources can help you out with. FHIR has something we call the conformance layer, and there are a lot of FHIR conformance resources. You see a lot of them on this screen, where we can take a look at specific resource types for content, for terminology, for operations, and for any other types of things. A couple of them I want to well, walk through with you. The most important one, or at least the thing that you might encounter first when you are going to do some profiling, is the structure definition resource. That structure definition defines data structures, so that could define a data type or a resource type, and it can define extra constraints that you put on any resource or data type. Also, structure definitions are used when you want to create extensions, or when you want to create logical models as well, you will use the structure definition resource. Well, we will see a little bit more up close what that structure definition looks like in a couple of the next slides that I have for you. Another of the FHIR conformance resources is operation definition. Within an operation definition, you can describe your operation with the input and output parameters used for that operation. Of course, also a description of the behavior or the expected behavior of that operation, and on which resource or resources that operation works. They can then be used for implementers to extend the API or restrict things on them. If you look at the FHIR search parameters for each resource type, there are a lot of standard search parameters available to you already. Sometimes you will have the need to create an extra search parameter. You can do that by creating a search parameter resource. You fill that with the details, for example, for which resource type this search parameter is available, and where to look for inside of a structure. So which field would be the field to use as the indexed value for that particular search parameter. The capability statement resource can be used in a couple of ways. So you can use a capability statement resource in order to describe the requirements, the capabilities that a system needs to have in order to be able to connect to a specific context or use case that you describe. Also, it can be used to describe the actual capabilities of a system itself. Actually, whenever you have a FHIR RESTful server, you will have to have that system be able to generate a capability statement upon request. You can see in the picture on this screen, you can see a small example there of the FHIR server that we have. And well, you can see that from the RESTful part, it will list all of the resource types that this system supports. So it lists all of those resource types, it lists all of the search parameters, it can list the formats that it supports, and all kinds of things like that. What you can also do inside of a capability statement is link to any of the profiles that you are using on that system in order to indicate support for that particular profile, or even indicate that you're limited to just using that particular profile on this system. There's also something called a structure map, and that will be able to hold the relationships between two structures. This is based on the FHIR mapping language. So from the FHIR mapping language, you can create a structure map resource, which is the FHIR equivalent of that particular mapping language file that you could have. Well, I do know that two of my colleagues are working on a Let's Build session for the mapping language. That session is probably not recorded, but the information session they did yesterday was recorded. So if you only hear about structure maps and the mapping language just now, then that could be a really good session to review later on. Another thing that the FHIR conformance layer has is implementation guide resource. With that implementation guide resource, you can describe in a structured way the things that are needed for implementing against a certain context or use case. So this can hold, well, HTML or Markdown pages, you can have links to them, and you can have links to all of the other FHIR conformance resources that are needed for your use case. And well, as you can see from this slide, that is exactly what is meant there. So from within the implementation guide resource, you point to all of those other structures, plus you point to a bit of documentation structure in the form of HTML pages, add some images, etc. Now, I've mentioned that the structure definition is used to describe data types and resources. And this is exactly what the FHIR specification itself does as well. So you will see that all of the FHIR core spec is defined inside of these structures. So all of the core data types, all of the core resources, core extensions, they are all described in core structure definitions. And we, when we are going to profile, are going to use those core structures in order to create our own profiles. Also, all of the other conformance resources, where applicable in the FHIR specification, they have used those resources as well. Now, important to know is that all of the conformance resources will have to have a unique identifier. That unique identifier takes the form of a URI. The author of that conformance resource is responsible for creating a unique URI for that particular conformance resource. And wherever that resource travels, it will always keep that same unique identifier. So we call it a canonical URL, and that is the thing to use whenever you are searching for a particular conformance resource. Of course, if you know FHIR, you know that whenever you create a structure or a resource on a server, it will also get a technical ID. But that technical ID will be different from server to server. So if you post your conformance resource to the Vonk server, it will get a Vonk assigned ID. If you post it to the Happy server, it will get a Happy server signed ID. That is the thing that will change. It's unique per instance of that conformance resource. But that is why we have this canonical URL, which is really important to think about and have on your structure. Most conformance resources will have them as a mandatory URI inside of there. Some don't, but I still would recommend to put them on in order to uniquely identify that conformance resource. There's two examples there. You can see that usually we take the convention of having the name of the particular conformance resource type inside of that URL. It's not mandatory, but it's a convention that most people adhere to. Okay, so that's an overview of all of the FHIR conformance resources. And of course, in my first slide, I had a couple of them listed that I cannot have time for to explain, but please do ask your questions in the Q&A. I will review everything that I don't get around to today later on, and I will answer all of the questions that get unanswered during this session. Okay, so when we are going to create our own profiles, we are going to define constraints. We are going to define constraints on a core data type, a core resource, or we can take another FHIR profile that someone else created and then make constraints on top of that. Sometimes the term profiling is also usually loosely used for referring to an implementation guide or a conformance package, which is actually the whole set of conformance resources for a particular context or use case. But when I talk about a profile, I really mean that particular constraint on another profile or a core data type or resource. Well, of course, if you are going to take a look at what's out there in the world, we will see that we have a set of core profiles. That's the FHIR core structure. All resources will always conform to the core profiles. And then, of course, we can take that layered structure where you can have profiles that depend on the core profiles, regional profiles that constrain the national profiles even further, and then a lot of organizational or use case specific profiles. So in the end, we will have a lot of use case specific profiles and just a couple of resources that conform to them, but all resources will always conform to the limited set of core profiles that you have out there. Now, profiling is done, as I said, with a structure definition, and that takes a little bit of metadata like that canonical URL I mentioned. But of course, you can also provide any information about the author, about the status, etc. in that metadata part of the structure definition. Then the real work is in the list of element definitions that you can put inside of that structure definition. You will see that the structure definition has a field called differential, and that will hold 1 to star element definitions. Those element definitions, they define exactly what the field name is, what the cardinality of that field is, what the data type is that is used. Also, if you have any default or even fixed values, that is put inside of that element definition. So that's why I say that is where all of the work will end up in. So whenever you use a profiling tool, then you will see that list of element definitions growing. The more changes you make, the more constraints you add to your profile. I can't stress enough that it is important to publish your work. So you can publish your work to a repository that can be a public repository, but could also be your own FHIR server if you have that. As long as at least you make your work visible so others can then retrieve it, can use it to create their own UIs, validate resources, at least also know what is expected of them to communicate when they want to connect to your use case. Now, if we look at a FHIR resource instance, so for example, the observation resource that I have on screen now, we can refer within that resource to a particular profile. This is done in the meta tag, meta.profile inside of the resource. You set that profile tag to the canonical URL of the profile you claim conformance to. So this is a claim. That means that whenever it's important to know whether this really is an observation that conforms to this particular mentioned profile, you will have to resolve somehow that profile URL in order to get the structure out of the system. So you could do, in this case, look up on the acme.org FHIR server. Then that will result, hopefully, in a structure definition being sent back to you. And then you can use that structure in order to validate your observation resource against that observation profile. So that can be done. Of course, not everyone has the option to have their own FHIR repository, so you can also use a public repository like simplifier. Sometimes you will find in the FHIR specification that you don't have a field available for the data that you also want to communicate. So think about patients' race and ethnicity. They are things that are mandatory in the US, but in many countries in Europe, it's illegal to communicate that data. So that cannot be put on the FHIR core structure, because if you put that on the FHIR patient, then in the US it can be used, but in Europe you can't use the FHIR patient. So they have taken that field out of the FHIR patient. It's not possible, by default at least, to fill it in. So if you still need that data to be on the FHIR patient, you will have to create an extension. There are standard extensions available already. So for patient race and ethnicity, you will see that there is the US Core project that has already defined those, but you can also create your own. So again, if you are going to create your own extension, you will take a look at the structure definition resource. You will give it a canonical URL because that is what will be used on the extension. And you will detail the details of where this extension can be put, because almost every part of every FHIR resource can be extended. So it can be anywhere inside of the FHIR hierarchy. And that is something that the extension author will need to determine. Can also be multiple paths as well if you need, but at least the author needs to define this. There will be a session about extensions later on today. So if you are interested to see more, then you could take a look at that one. Okay, so now we have our structures, our profiles, we have our extensions. We also have the capability of creating value sets and search parameters and operation definitions. In the end, you will have a whole set of conformance resources. That whole set can be packaged. So you could say, okay, I'm going to take all of these related FHIR conformance resources and then create a set out of that we call a package. That FHIR package can then be published somewhere, and it can also be consumed by any package consumer or package tool. There is, again, also a session, and that will be right after this one, about packages in FHIR. So, well, again, that is really interesting to take a look at if you are going to create your own profiles and conformance resources. One of the things that you could take a look at is the simplifier platform, because on simplifier you're able to create packages, but you can also find packages and then well, download them, and you will have the whole set of conformance resources that belongs together in one package. The Forge tool is also a form of a package manager, because within that Forge tool, you can do the same. You can consume the packages from Simplifier, and then you can well, use any extension that is in the package in your own profile, or you can create derived profiles from the profiles that are in those dependencies that you have. So a couple of slides left here about the tooling and the registries. As I mentioned, it's important to have a place where you can publish your work, and there is an official HL7 profile registry. There's also a registry for implementation guides, and in this case that doesn't mean implementation guide resources, but the complete set of information in the form usually of a website. So you can find them on those links if you want to. I did also mention Simplifier already a couple of times. Simplifier is the FHIR public FHIR registry. You can use Simplifier without having to have a login, so you can just search and browse for anything that you need. We have all the official HL7 profiles on there, so all of the standard core resources, data types, extensions, etc., they can be found on the Simplifier platform as well. And next to that, HL7 affiliates have the option to create a project for that particular country or HL7 affiliate profile project. If you are an organization that likes to work in private for a while before you really publish your work to the outside world, Simplifier can tailor to that as well by giving you the option to create private projects. There's other options on Simplifier too. For some of those options, you will need to have an account, and you can sign up with a free account in order to get a project. As of that moment, you will be able to use Simplifier to validate a resource instance against any profile that's on the Simplifier platform. Also, Simplifier powers registry.fhir.org. So whenever you find anything, any conformance resource on registry.fhir.org, you can click on it and then you will jump to the Simplifier platform for more details. Simplifier, as I mentioned, is also used to create the packages, and you can also create implementation guides on there. Now, this is an introductory session. Tomorrow we have a session where we will take a closer look at really creating profiles, and also my colleague will then give a demo at least to be able to create an implementation guide as well. So he will show a little bit of the options that you would have there. There is this slide here that lists a couple of the profiling tools. Of course, since I'm working for FHIR, I usually use our Forge tool for a lot of things, and I use our Simplifier platform. But if you do not want to use that, there's other options as well. I do not know for every FHIR resource type, conformance resource type, whether there is a tool or not. Some, if they are not too complicated, can be created by hand as well, just in an editor. I would not ever do that for structure definitions though. So please, whenever you are going to create your profile, just take a look at the options you have here. I don't care if you use the Forge tool or not, at least I will not follow you around to tell you to do that, but I will tell you not to create a structure definition by hand, because it's really easy to make mistakes in the structure within if you do not follow all of the rules. And of course, the tooling here knows about all of those rules, and they have implemented that correctly. It also does say example instances here. One of the things I usually recommend to do is whenever you create profiles, to also create an example instance, resource instance that conforms to that profile, just to show people again what is needed and what is expected of them to communicate as data. So that would be really helpful. If you take a look around the FHIR specification, you will also be able to see that the FHIR specification itself does that too. For each resource type on there, there will be at least one, and most of the time multiple examples that are conformant to that FHIR structure. So what's next? You can, of course, go to the next session about packages. As I mentioned, extensions are also on later today. Of course, I do hope to see you again during the introduction to profiling, the Let's Build session, where you will get some hands-on experience creating profiles. And I do another session about FHIR path tomorrow, which will detail some of the extras that you can put as constraints on profiles. So let me just check. I still have a little bit of time left, I think. So we will, let me see. Marianne, how much time do I still have?
You are at 10 minutes still.
Ah, okay. That's better than I thought.
Yes.
Usually I am scrambling for time at the end. So I'm just going to refresh my other screen to see if we have any other questions that, well, that have been created there. Okay, so I have 3 questions here. The first one is, could you explain more about the capability statement? Well, let me just see if I can just give you an example there. I will share my screen again so we can take a look at that. So what I have just done is also start Postman, which is of course a RESTful tool to send any RESTful requests. And as I mentioned, if you have a FHIR RESTful server, you will have to be able to generate this capability statement upon a request. Well, the request is this metadata at the end of your FHIR endpoint. Then within this capability statement, you will be able to see, well, some metadata here, some information about who is responsible for this. And then it will list in this RESTful part all of the types that are available. Now, this is a result from our test server. So we support all FHIR resource types, and we support all of the interactions on there. We support all of the search parameters on there, but you can get the idea. So this is one of the resource types that is called account. And then you can see that we have all of these FHIR RESTful interactions listed on here. And we have things like search parts here. Let me see if there's also the search parameters. So you will see all of the search parameters that we support. So this is basically the capabilities of this system listed in a structure. Because you have this structure, you could, for example, do some kind of handshaking. A client could request the capabilities of a server to see whether it supports the certain things that the client needs to have supported on that system side. So then you can decide in the client what to do. So that is what that capability statement is used for, at least when it is a capability of a specific system. The other option I mentioned was to create a capability statement resource as a template requirements for any system that needs to implement your use case. So on your implementation guide, you can point to that requirements capability statement and then say, okay, this is the minimum set of things that you need to support whenever you want to implement our use case. Does that answer the question there correctly? Not sure if who asked, but I could see that. The next question is, well, please do add to that question if you think that you want to have explained more. I'm happy to answer more there. But the next question is, what are the differences between layered profiles? Well, layered profiles, or also sometimes called derived profiles, mean that you take a structure that's already out there and then you derive from that and make extra constraints. So let me just show you quickly just do show you a demo in Forge. I thought I wouldn't have any time. I've opened my Forge project, Forge tool, sorry, and what I can do is I can create a new profile. Now, at this time, I do not have any existing profiles yet, so you will just be able to find all of the FHIR standard structures. So I can create a profile based on the FHIR core patient. And let me just say this, so I could just do my first patient there and create a profile. Now, if I then wait a bit, Forge will read in the FHIR structure and it will show me this UI. So Forge uses the standard FHIR structure definition for patient in order to show me this particular field here. And now I can start creating constraints. So I'm going to, for example, make things that are optional, make them mandatory. In this case, well, let's say that an identifier is always mandatory, but there can still be a star. So I can make this mandatory. I'm also interested in what the birth date is. And we can do a couple of steps like that. There's a lot of things that you can do with profiling, but as I said, the hands-on part tomorrow will detail more. But you can create these kind of constraints, and then you could save your profile. In this case, I'm saving to disk, but I could also upload to a FHIR server or to the simplifier platform that is in the file option. So I could just say publish to simplifier there, and then it would be put on the project that I have on simplifier. Now I have my first patient profile. Now what I can do is take a look at my structures here, and I can select this first patient, and I can create, no, I have to click, right click. I can create a derived profile. A derived profile, that's that layer of profiles derived from this first patient. So Forge will give you a standard option there. So let me just change that, my second patient. Okay, so the second one will already have all of the constraints that the first one had. So you can see that the identifier and the birth date are already mandatory. They were not in my previous example because that was just the base FHIR patient. And now I can work from this. What this is useful for is, for example, if you are in the US, you are probably mandated to use the US core patient. But for your own use case, even though you still want to use the US core patient, you might have extra constraints that you want to put on there. What you will do then is make a profile on US core patient instead of on the FHIR base patient. So you, as an advantage, get all of the work that HL7 has already done for creating that US core patient. You will get them as a present. You will derive from that. So you will always be conformant against the US core patient when you have your own patient derived from that profile, because, well, you can only constrain things further. You can make things more specific and you cannot make it more lenient. So I could not say, okay, but in my case, I do not want that identifier. As you can see, Forge will not let me set this to 0 to star again. That is, of course, because I have derived from this profile. So
Mirjam,
that layered.
I just want to give you your 4 minutes.
Okay, thank you.
You bet.
So that layered profiling is useful for that. If you already have a mandate to use a particular set of profiles and you want to work on that. Or if your organization has an overarching organizational profile for a particular resource type, and per use case, you might have a couple of differences. You base all of them on that overarching profile and then work from that to create your own specifics on that. Okay, so let me see if there are, the questions are coming in here, so that's good. So you are trying to, well, at least interact with me there. Thank you.
Mirjam, if you'd like to, we can leave this open so you can answer all the questions on the call or on the presentation.
So for the, that people can unmute, you mean?
If you'd like, or you can just go through the questions, whatever you'd like to do.
yeah, if there's anyone who wants to ask me a question, that would be great as well. I would love that. And of course, any question that doesn't get answered by talking to you, I will answer by typing in the chat. So is there anyone who has a particular question?
Hi, this is Daraj.
Hi.
I work for New York eHealth Collaborative. We are like a New York State designated entity. And we are working on some of the public health use cases where we are trying to get the kind of COVID data out to the public health use for the public health purposes. We were thinking to use the US core profile for the patient information, but there are certain resources where we don't find the any profile for that. So,
Okay.
for example, is like the there was a sorry, I forgot the resource name, but that resource we are going to use it, but it doesn't have a profile. So, is there a way for us to just create it and along with the US core, or
yes,
how it works?
So I've just opened up the US Core implementation guide, and you can click on that link for the US Core profile. So there's already quite a lot available. But yes, if you have any resource type that is not already profiled, I would do two things. I would reach out to the people creating these profiles. They have some contact information in this implementation guide if you want. So that's one step, just to let them know what you're doing, and perhaps that you can communicate with them and discuss whether your profiles need to be taken into the US Core project. But if there is no necessary means to put them in, of course, you can create your own profiles. What you can also do is within your profile, then say, okay, for whenever there is a link to a patient, that has to be a link to a patient conforming to the US Core patient. That's something that you can change on the profile. Okay. So that would be really useful to connect at least any profile that you create with any of the things that might be on the US Core already, and align with that. Yeah. But if it's not there yet, then it's up to you to be the first one to start creating, and then hopefully also communicating that back to the US Core project to see whether it needs to be taken into that.
Okay, and just a quick question. You don't need to answer that. You can just put it in chat too. There is a IHE profiles for PICS query. Is that something part of the simplifier? I mean, is that loaded into the system if I want to search for that?
I'm not sure if it's on simplifier. I do know that that's the IHE means of, well, if it has the M, it's the FHIR way of working with that. So they do have a description, and they do have some, like an operation definition that they have at least described. No, I'm not sure if that project lives on simplifier. It's up to the authors of those conformance resources to create such a project on simplifier. As long as it's not the core, we will not touch any resources that are outside of our company.
Got you. So if you have a link or anything, if you want to put it on chat, that would be helpful.
For the IHE? Okay, yeah, okay.
Thank you.
Okay, so are we out of time already, Marianne?
It's up to you. You can keep going if you'd like to answer more questions.
Okay, so but the official time for the session is over, right?
Correct.
So anyone who needs to drop out to go to the next session, thank you for your attention, and hopefully you can put some questions my way. You can always message me as well in the Whova app. Anyone that wants to linger on and ask me another question, please do so, and I will be happy to answer a bit more, because I'm not needed necessarily in the next session.
And are you on a Zulip chat? I mean, can I put the question to you on the Zulip?
Yes, yes. I will receive that at least. I'm not often on the Zulip chat, but if you just reach out with me to me with a direct message, then I will be happy to answer it there.
Okay.
So it should just be my.
Is there any other way to do the communication?
So that's, well, if you send me a message through the Whova app, that could be one that I'm on Whova during this whole DevDays still. So
Yeah, so if you don't mind, like if you actually, I joined the session a little late. If you want to just put your full name so that I can find it and find you.
Yeah. So I'm not sure. So that's just Mirjam Baltus. So that is. There's also my name is also in my PDF that is on the Q&A. So if you click on that one, you will be able to find my name in there.
Okay, sounds good. Let
Okay.
me see the PDF.
Yeah. Okay. Anyone else who still wants to ask me something? Then please unmute and go ahead. Or type it into the chat and I will answer it after the session ends. Okay.
Looks like it.
I'm not hearing any more questions. So again, thank you all for your attention and well, thank you for being here. Hopefully we'll see each other again.
Yep, great. And everyone, the next sessions will be starting in about 2 minutes. So enjoy. Thanks so much.